Bismillahirrahmanirrahim. My name is Ayesha Gull, and today the topic of my presentation is characterization of bacterial isolates from diseased Labiorrhea and their control through selected plant extracts. This research was supervised by Professor Dr. Muhammad Qasim, Department of Microbiology, Kohat, University of Sciences and Technology, Kohat. Starting with the outlines of my presentation, first of all, we start out with the introduction, then rationale, objectives, methodology, and at the end, references. Starting with the introduction of my research work, as you know, that aquaculture that plays a vital role for global food security, contributing significantly to the protein intake and ultimately development of economy. Fish as an essential source of high protein content containing omega-3 fatty acids, some vital micronutrients playing a crucial role in global nutrition. They contribute significantly to the health of the human economy sustainability, particularly in developing countries where fish farming that supports livelihoods and ensures food availability. Labiorrhea, as it is commonly known as Rahu, it is a freshwater species belonging to the family Cyprinidae. It is widely distributed across the South Asian countries, particularly including the India, Pakistan, Nepal, and Bangladesh. It is one of the most important carp fish in aquaculture due to its high commercial value, its fast growth rate, and nutritional benefits. Diseases in fish, as disease outbreak in fish, it includes bacteria that possesses a significant threat to fish health, its production rate, leading to high mortality rates and economy loss. To control these fishes, many type of different antibiotics they are being used. These antibiotics that have shown a successful rate of treatment against these bacterial diseases, reducing its mortality rate, improving the fish health. But however, due to the overuse of these antibiotics in aquaculture, that leads to emergence of antibacterial resistance, rendering to many antibiotics that become ineffective. To control these fish diseases by increasing the failure of some conventional methods, including the antibiotics, some alternative strategies should be used for these disease controls. These strategies include some oil extracts, plant extracts, mucus extract, microbial extracts. Among these eco-friendly approaches, plant-based antimicrobial have gained a significant attention due to its bioactive compounds. Plant contains some secondary metabolites which possesses some potent antibacterial activity. Rationale of my research work as Pakistan aquaculture industry, it relies heavily on Labiorrhea, its high market demand, nutritional value, and fast growth rate. However, bacterial infections that significantly impact its production, leading to a loss of economy and its reliance mainly on the antibiotics. The aim of the study is to explore plant-based alternatives for controlling bacterial pathogens in Labiorrhea, offering a sustainable solution to reduce the antibiotic dependency and mitigate antimicrobial resistance. The objectives of my research: number one, to isolate and phenotypically identify bacteria from infected Labiorrhea, to determine the molecular drug resistance pattern of bacterial isolates, to evaluate the antibacterial potential of selected plant extract against isolated bacterial pathogens. My research methodology: first of all, we started with the collection of samples, different infected fishes of Rahu. They were collected from different ponds, farms of district Kohat. Then these were subjected to the dissection. After the dissection, different bacterial samples, they were collected through swabs from different organs of the fish, internally and externally. And then they were cultured on a nutrient agar, and phenotypically they were identified by using API kit E20. And then antibiotic sensitivity test was done. Then different medicinal plants, they were collected from Orgzai agency, and plant extract were formed. And then we again find out the activity of plant extract against these isolated bacteria from the infected fish. These are the results of my research. The total bacteria that were identified were 106. Out of these, the bacterial distribution were that 34% include the Pseudomonas species, 26% include the Klebsiella species, 20% were Aromonas species, and 10% includes E. coli. Apart from that, gram-positive includes Staphylococcus species that were 5%, and then Salmonella species include 5%. This is the result of my antibiotic resistance. Almost 5 group of antibiotics that were being used against these isolated bacteria, mostly bacteria, that showed the resistance to beta-lactam group of antibiotics. Then the plant extract effectiveness was measured by zone of inhibition. Calotropis procera, a medicinal plant, it showed the zone of inhibition that was 40 mm against Staphylococcus species. Asdricta indica, that showed 22 mm zone of inhibition against Aromonas species. Caricluma tuberculata, 35 mm against Klebsiella species. Meloneglecta, that is a common mallow, that showed the zone of inhibition that was 37 mm against Pseudomonas species. So we concluded that the gram-negative bacteria, that includes Pseudomonas species, Klebsiella, Aromonas species, that were mainly isolated from disease Labiorhita, and all the selected plants showed potent antibacterial activities, indicating their potential as alternative and eco-friendly therapeutic agents for the management of bacterial infection in aquaculture. And at the end, these are the references of my presentation. And thank you so much for listening to my presentation. Thank you all.